Hello everyone and welcome to the chapter number 42 of Blender Master Course Geometry Nodes Creating a Candy World Part 1. In this chapter and the upcoming chapter, we'll be learning about lots of new geometry nodes and we'll use them to create this amazing scene of a candy world in Blender. And for this chapter, we'll be starting with the understanding of all of these geometry nodes. And yes, if you are new to this course, then do check out the previous 42 chapters from the link of the playlist in the pinned comment. So to begin with, let's first open the geometry nodes workspace from here, and with this cube selected, go to the geometry nodes editor and click on the new button. Now the first node that we'll be exploring today is the geometry to instances node. So to add it, press shift plus A, go to geometry and select the geometry to instance node. Let's place it over here, and one thing to keep in mind is that this geometry to instances node is very similar to the join geometry node. You can see that just like the join geometry node, this one is also having an oval shaped socket as the input, which means that you can connect multiple inputs to it. To understand it practically, I will add another mesh in the scene by using geometry nodes. So press shift plus A, go to mesh, and in primitives, you can randomly select any mesh primitive. For now, I'll be choosing the cone and place it over here. If I take this mesh socket and connect it to the geometry, then you will notice that we are now able to see both the original cube whose information is stored in this group input node as well as the cone that we added in the geometry nodes editor. But you might be thinking that the same function could be performed by join geometry node as well, because if I press shift plus A, go to geometry and select the join geometry from here, and then if I break the node connection in between these two nodes and the geometry to instance by holding control, right clicking and dragging like this, and instead if I connect both of them to the join geometry node and then connect it to the output, then in this case also you are getting a similar result. However, there was one slight difference which you might have noticed here. With the join geometry node connected, both of these geometries, meaning the cube and the cone, are joined together into a single geometry. However, in case of the geometry to instance node, both the geometries are not converted into a single geometry, but instead they are converted into different instances. So if I press Ctrl plus Z to undo 6 to 7 times, then with this geometry to instance node connected to the geometries, you can see here that this cone is a separate instance object and the cube is a separate instance object. And this was not the case when we were using the join geometry node. For now, I'll delete this join geometry node from here, and since we are using the geometry to instance node, you can remember it in this way, that it takes these geometries as the input and the output is in the form of instance. Now moving ahead, I can use these instances to be placed at different points by using the instance on points node. So let's understand this also by pressing shift plus A in the instance, select the instance on points, and we'll drop it after the geometry to instance node. Right now, this instance socket is connected to the points, but we'll disconnect it from here and connect it to the instance. Now suppose you want that these instances should be placed on the points of a plane, then for this we'll be connecting the grid node to the point socket. So press shift plus A, go to mesh, and in primitives select the grid node. Let's drop it over here and we'll connect it to the point socket. Now let's scale up the grid in the X and Y axis from here. So we'll change it to something like 7 or 8, and if I turn on the pick instance option here, then now you will notice that the different geometries, meaning the cube and the cone, are now being placed as separate instances on the points of the plane. And I turned on the pick instance so that no two objects are placed over each other. And see, this is the advantage of adding the geometry to instance node. If I would have used the join geometry node, then in that case it would have joined the two geometries into a single one, and we would obtain the result where all the points are having the same instance, which is the cube joined with the cone. Now moving ahead, let's create some candies for the candy world scene, and for this press X to delete all of this, and first we'll be making a lollipop. So let's add a cylinder by pressing shift plus A, then in the mesh select the cylinder from here, tab into the edit mode, press S and Z and scale it down like this. Let's come out of the edit mode and turn on the render view from here. Now to give it some material, let's go to the material properties and create a new material. We'll change its name to lollipop and press enter to confirm. Now let's go to the shader editor from here, and we'll be creating a material like this one for the lollipop, and for this we'll be using a completely new node which we have not yet used for creating any material in this course, and it is the gradient texture node. To understand it, we'll first add it in the shader editor. So press shift plus A, go to texture, and here we have the gradient texture. So let's select it and place it over here. Press Ctrl plus T to connect it to the texture coordinate and the mapping node. To view the texture on the cylinder, hold down Ctrl Shift and left click on the gradient texture. Now just like always, I'll take the object socket and connect it to the vector, and here you can see that it's creating this gradient texture, and it looks like this because we have selected the linear gradient type here. If I change this gradient type to something else like diagonal or spherical, then you will notice that the gradient is being applied according to that specific type. You can understand it in this way, that with the help of gradient texture, it will basically basically show you the mixing of two colors, and by default the colors are black and white. So in this case, on the outer side of the face you are having this black color, and as you approach the middle the color slowly turns into white. Similarly, if I change it to radial, then in this case it will take the Z axis into consideration and the change in color will be from black to white in a circle like this. Now one more thing to notice here is that in one of the previous chapters I told you that in Blender the black color is represented by 0 and the white color is represented by a value of 1. So you can also say that here the value is equal to 0, and as you complete the circle then in the end the value is equal to 1. But suppose you want to change this ending value, like maybe you want to create a texture where the value changes from 0 to 0.5, and to achieve this result we'll be using a math node with a special operation known as ping pong operation. To add it here, press Shift plus A, go to converter and select the math node, drop it over here and change the operation from add to the ping pong here. So I'll select this, and now with the scale value I can choose that particular value of the color at the ending position. For example, if I change the scale to 1, then it's the same default result which shows the texture from a value of 0 to 1, and if I change the scale to 0, then now everything will turn black because the gradient texture will now operate from a value of 0, which is the black color, and will also end on 0, which is again the black color. So you can change the scale value to anything between 0 and 1, but for now I'll change it back to the default one. Now to multiply this effect or basically get more of this texture here, we'll simply add another math node with the multiply operation. So with this one selected, I'll press Shift plus D and place it over here, change the function to multiply, and now I can increase this value to multiply the effect. So let's keep it to a value of 10, and this is how it looks now. The texture is basically going from 0 to 1, then because of the multiply node it again goes from 0 to 1, and similarly this happens 3 more times. Now moving ahead, let's also give some colors to this lollipop, and we'll be using the color ramp node for this. So press Shift plus A, go to converter and select the color ramp. Let's place it over here and change the interpolation type to constant. Now we'll be using this color ramp to set 3 different colors for the pattern of the lollipops in such a way that whenever I create a duplicate of it, we get a different color each time. So for this, I'll first change this black color by increasing the brightness, and let's keep it to the blue color. Now let's select the white pointer and change its color to the green color, and to add one more color in this color ramp, click on the plus icon and change the color to red color this time. Now let's properly place them so that all the 3 colors are evenly distributed in the color ramp node. And yes, there's also one shortcut by using which you can evenly distribute these pointers, which is to click on this drop down and select distribute stops from left, and now they will get distributed at equal positions from each other. Now I'll be adding another color ramp which we will be using in order to change the thickness of this pattern. So press Shift plus A, go to converter and add the color ramp. Let's place it in between this ping pong node and the material output and change the interpolation to constant. Now if I select the white pointer and move it like this, then you will notice that I can easily change the pattern of the lollipop. So we'll be using the first color ramp to give some colors to it and the second color ramp to change the pattern of the lollipop. Now in order to mix both of them, we'll be using the mix color node. So press Shift plus A, go to color and select the mix color node. Let's drop it over here. We'll connect this color ramp with the different colors to the color B, and now we have this red color applied to this lollipop. However, if I create a duplicate of this object by pressing Shift plus D, then you will notice that this one is also having the same color. But to assign different colors to each of the duplicates, we'll be using the object info node. So press Shift plus A, go to input and select the object info node from here, and in this node you can see that we have a random socket. So if I connect it to the factor, then this will give a random color to the pattern each and every time we create a duplicate. So now if I press Shift plus D to create a duplicate, then this one is having a red color, and similarly if I do it one more time, then this one is having the green color. So this was the use of the random socket in the object info node. For now, I'll delete both of these duplicates by pressing X, and let us select this one. Now to give it a 3D bump effect, I'll first connect the principal BSTF here, and to add the bump node, press Shift plus A, go to vector and select the bump node. Let's place it over here and connect it to the normal in the principal BSTF. For the input, we'll be using the noise texture node. So press Shift plus A, go to texture and select the noise texture from here, and we'll be connecting it to the height socket of the bump node. Now I'll take the object socket in the texture coordinate node and connect it to the vector in the noise texture. Let's also change the scaling and the strength of the bump effect. So first of all, I'll increase the scaling to something like 14-15. Let's reduce the strength of the bump effect to a very low value like 0.1 or maybe 0.05. Let's go to the top view in order to see the material properly, and to make it look shinier, I'll go to the roughness option in the principal BSTF and let's reduce it to something like 0.1, and now it is having a very shiny surface. Now for the stick of the lollipop, go to the edit mode, press Shift plus A and add a cylinder. Let's scale it down in the X and Y axis simultaneously. So press S and Shift plus Z and scale it down like this. Left click to finalize, and to rotate it, press R, Y and type 90 in order to rotate it by 90 degrees in the Y axis. Press G and X and move it over here, then left click to finalize, and to assign it a specific material, go to the material properties, click on the plus button and let's create a new material. So I'll change the base color to something like brown. Let's reduce the brightness from here and make the base color dark brown. Then click on the assign button, and now let's come out of the edit mode. Now if you want that the lollipop should be more curved or rounded, then for this you can use the bevel modifier. To apply it, go to the modifier properties, click on add modifier, and in the generate, select the bevel modifier. Now I can use the amount value here in order to change the amount of bevel. So I'll keep it to something like 0.05, and now this is how this lollipop is looking in the scene. Now moving ahead, we'll also be creating a gumdrop candy. You must have seen it. It has these small sugar crystals over it, and to model it in Blender, we'll first add a cube in the scene. So press Shift plus A, go to mesh and select the cube, press G and Y and move it over here, and now we'll be applying the subdivision surface modifier. So go to the modifier properties, click on add modifier, and in generate, select the subdivision surface. Let's increase the levels viewport to a value of 2, and this is how it looks. Now to make it look smooth, simply right click and select shade smooth, and to give it a shape like a gumdrop candy, tab into the edit mode, press Ctrl plus R to create a loop cut, then left click and move it down like this. And once you finalize the position, left click to confirm, and now let's create the material for it. So go to the shader editor again, click on the new button. Now to get random colors for each gumdrop candy, we'll be using a color ramp node. So press Shift plus A, go to converter and select the color ramp. Let's place it over here and change the interpolation type to constant. Now I'll change the color of the black pointer by increasing the brightness from here, and for the first one, I'll be selecting the pink color. Then I'll select the second pointer, and for this one, we'll be choosing the green color. To add another color, click on the plus button and change its color to the yellow color this time. And yes, one more thing, you can select any random colors here. It's not mandatory that you have to select only these particular colors for the gumdrop. Now to distribute these pointers evenly, I'll click here and select distribute stops from left. Now I'll take this color socket and connect it to the base color, and to get a random color each time you create a duplicate, let's add the object info node. So press Shift plus A, go to input and select the object info node. Let's drop it over here and connect the random socket to the color ramp. Now if I create a duplicate of this, then we'll get different random colors. For now I'll delete the duplicate and select the original one again. Now to give it a 3D bump effect, go to the shader editor, press Shift plus A, go to vector and select the bump node. Let's drop it over here and connect it to the normal in the principal BSDF. For the input, we'll be using the noise texture node. So press Shift plus A, go to texture and select the noise texture. Let's drop it over here and connect the factor to the height socket. Now to make sure that the texture is properly applied, I'll select the noise texture, press Ctrl plus T in order to get the texture coordinate and the mapping node. Now just like always, connect the object socket to the vector, and this is how the bump effect looks now. I will reduce the strength in the bump node to something like 0.1 or 0.08. Let's also change the scaling in the noise texture in order to give it a random look. So we'll keep the scaling to something like 11, 12, and this is how it looks. It now has this slight bump effect applied to it. And now to distribute some sugar crystals all over this object, we'll go to the geometry nodes editor from here and click on the new button. Now press Shift plus A, go to point and select distribute points on faces. We'll drop it over here. Now to place sugar crystals as the instances in place of these points, we'll be using the instance on points node. So press Shift plus A, go to instances and select the instance on points. Let's place it over here. Now everything will disappear because we have not connected anything to the instance. So let's make the sugar crystals to be used as the instance here. So in the 3D viewport, press Shift plus A, go to mesh and select the cube, press G and Y and move it over here. And to make it look like sugar crystals, we'll go to the material properties from here, click on the new material, and we'll be making it transparent. So go to the transmission and increase the weight to a value of 1. Now since we are in the Eevee render engine, so we need to do some more changes in order to get the material properly. So first of all, turn on the screen space reflections from here, and if I click on it, then here I have the option of refraction. So I'll turn this on as well. Now go to the material properties, scroll down and open the settings, change the blend mode from opaque to alpha blend and turn on the ray trace refraction. To view the sugar crystals on the candy, I'll select this cube from here, which is basically the gumdrop candy that we created, and to use the sugar crystal as the instance, I'll select this cube.001 and drag it into the geometry nodes editor. Now take this geometry socket and connect it to the instance. To view it properly, let's go to the solid mode, and you can see that the size of the instances is too high. So we'll change the scaling from here. So I'll select all the 3 axes and reduce it to something like 0.02, and to view the candy along with the crystals, we'll be adding the join geometry node. So press Shift plus A, go to geometry and select the join geometry node. Let's place it over here. Now take the geometry socket in the group input node, which is carrying the information about the original candy, and drop it into the geometry socket of the join geometry node. Let's go to the render view again, and this is how this gumdrop candy along with the sugar crystals is looking right now. Let's also increase the number of these sugar crystals from the density option here. So let's keep it to something like 40 or 50, and this is how it looks. If you want to get a better view of the candy, then go to the render properties and change the render engine to cycles. Now one more thing that you can see here is that the shadows of these sugar crystals are visible on the candy, and to solve this problem, simply select this bigger sugar crystal that we created, go to the object properties from here, then in the visibility, you have the ray visibility, and here one of the options is shadow. So if I turn it off, the shadows of sugar crystals crystals will no more appear. However, to bring it into effect for these instances as well, simply select the candy and in the object info node carrying the sugar crystals, turn on the as instance option. And now you can see that the shadows of the sugar crystals are no more present on the candy. So basically, you can use the as instance option if you want that the change you did to the main object should also be applied to the instances. And with this, these two candies are now completely ready and we'll be placing them on different points of a plane. So for this, I will first select this sugar crystal and hide it in the viewport as well as the rendered version. Then I'll select both of these candies, press G and Y and place them over here. Now press Shift plus A, go to Mesh and select the plane, go to the Geometry Nodes editor and click on the new button. Now tab into the edit mode, right click and select subdivide, and let's also scale it up like this. Now come out of the edit mode. To place these candies as the instances on different points of the plane, we'll first add the instance to points node. So press Shift plus A, go to instances and select the instance on points. Let's place it over here. Now we'll bring the object info node for both the candies. So I'll first select this cube, which is the gumdrop, and drop it over here. Similarly, I'll go for the cylinder, which is the lollipop, left click and drag it over here. Now since we need to use both the objects as the instances, so we'll be using the geometry to instances node. So press Shift plus A, go to geometry and select the geometry to instance, drop it over here, connect this geometry socket to the geometry to instances. Similarly, connect this one also, and now take this instances socket and connect it to the instance here. Right now they are being placed over each other because we have turned on the pick instance option. So I'll turn it on, and now we have the two candies placed as instances on different points of the plane. Let's also reduce their size from the scale option slightly. So let's keep it to 0.9, and this is how it looks now. Now moving ahead, we'll be creating the base where we'll place all these candies. So for this, let's add a grid node here. So press Shift plus A, go to Mesh and in primitives select the grid node. Let's place it over here, and now we'll connect it to the point socket in the instance on points node. Let's also increase the size of the plane from here. So we'll keep it to something like 6 or 7. Now in order to view the plane along with these instances, or basically the candies, let's add the join geometry node. So press Shift plus A, go to geometry and select the join geometry node, place it over here and connect the mesh socket of the grid node to the join geometry. Now here we have this plane in the scene. Now if you remember, when we were making mountains in some previous chapters, in order to convert a plane into a mountain, we were using the noise texture node in the geometry nodes editor. We used it to displace the vertices in a particular direction and make hill-like structures. So just like the noise texture, we can also use some other textures like the Warner texture in order to create some random pattern on this plane. So for this, we first need to add the set position node. So press Shift plus A, go to geometry and in right, select the set position node. Let's place it over here, and now also connect this geometry socket to the point socket in the instance on points. Now we'll be using this offset socket and we'll connect it to the Warner texture in order to see its effect on this plane. So press Shift plus A, go to texture and select the Warner texture. Let's place it over here. Now I'll take the distance socket and connect it to the offset. And now if I change the angle, then you can see that the vertices of this plane are now slightly displaced. The reason why the effect of this Warner texture is very low is that the number of vertices in the grid is set to a very low number. So let's increase it to a much higher value like 24, and because the number of vertices has increased, as a result, the number of these instances, or basically these candies on different points of the plane, has also increased. To solve this problem, we will use the random value node and connect it to the selection socket. So press Shift plus A, go to utilities and select the random value node. Let's place it over here. We'll change the data type from float to boolean, and if I connect the value socket to the selection in the instance on points, the number of these instances or the candies will reduce, and that's because the probability value in the random value node is set to 0.5, meaning that for each point, the probability or the chances of having a candy placed at that vertex will be equal to 0.5. So to further reduce the number of these instances, I'll reduce the probability to a very low number like 0.05, and now we only have these few candies in the scene. In order to view and understand the Warner texture properly on the plane, I'll reduce this probability value again and we'll keep it to something like 0.01 for now. Now you can see here that the effect of this Warner texture is too high right now. To reduce it, simply go to the scale value and let's bring it down to something like 0.5, and this is how it looks now. Right now, the effect of the Warner texture node is being applied in all the three axes. However, to get this effect only in the Z axis, we have to use the CombineXYZ node. So press Shift plus A, go to utilities and in vector, select the CombineXYZ node. Let's place it over here, and to connect this socket to the Z axis, first I'll break this node connection and then I'll take the distance socket of the Warner texture and connect it to the Z axis. So with this we have the effect of the Warner texture node applied to the vertices of this plane in only the Z axis. Now if you want to increase the size of this plane, first I'll select these two candies. Let's hide them by pressing H, and if you want to hide them even from the render view, then click on these camera buttons. Now to increase the size of this plane, go to the grid node and let's increase the size to something like 25, and let's also increase the number of vertices here. So I'll select the vertices in the X and Y axis and let's increase it to a much higher number like 70 or 80, and this is how it looks. The plane is having the walnut texture applied to it, and the number of candies have increased because we have increased the number of vertices from here. Now to improve the lighting in the scene, I'll select this lamp and will change its type from point to sun. Let's reduce the strength of this light from here. So let's keep it to a value of 10, or maybe let's reduce it to 5, and then to adjust the rotation of this light, press R and move your cursor like this. Then left click to finalize. Now one more problem that we have in the scene is that these candies are not placed properly, like all of them are passing through the plane. And to fix this problem, we first need to get the original candies back in the scene. So go to the scene collection, let's unhide them from here, and I'll be selecting both of them from the scene collection. So I'll select the cube, which is the Gumdrop Candy, hold down the control button and select this cylinder, which is the original lollipop. Now press G and Y and place it over here. And now to move these instances upwards, I'll select the gumdrop first, tab into the edit mode, press A to select all, then move it upwards by pressing G and Z, and in this way, when I move it in the edit mode, all the instances will also begin to move in the Z axis. So let's finalize this position by left clicking and then come out of the edit mode. Now I'll select this lollipop, tab into the edit mode, press A to select all, and we simply need to rotate it. But if I press RY and rotate it like this, then you can see that the texture that we applied on the lollipop is also getting changed. So to solve this problem, first I'll undo the rotation, come out of the edit mode, select this plane, and in the geometry nodes editor, you can see that we have this object info node with the cylinder selected, which is the lollipop. So to rotate it, we'll be using the transform geometry node and connect it after the object info node. So press Shift plus A, go to geometry, and in operations, select the transform geometry node. Let's place it over here, and now if I try to change the rotation like this, you will notice that the texture is still getting changed. So simply go to the object info node and turn on the as instance option, and after this, we'll get back the original texture. Now in the rotation, I'll change the value in the Y axis and round off it to minus 90 degrees, and let's also bring it upwards in the Z axis. So I'll keep it to something like 2.5, and this is how it looks. Now I think that there are too many candies in the scene, so I'll change the probability from the random value node and we'll reduce it to something like 0.005, and we now have lesser number of candies. Now moving ahead, at the center of this plane, we'll be making a cotton candy tornado, and to create the basic structure of the tornado, we'll be using a node which is the curve spiral node. To add it over here, press Shift plus A, go to curve, and in primitives, select the curve spiral. Let's place it over here. To view the curve spiral in the scene, hold on Control Shift and left click on the curve spiral node. Let's also go to the solid mode for now, and here we have the simple curve spiral added in the scene. Now the first option that you have in this curve spiral node is the resolution, which is basically the number of points in the curve spiral node. Higher the resolution, smoother will be the curve spiral, and it will have a much better look. Then the next option that you have is the rotations, and it simply means the number of rotations in a fixed length of the spiral. Right now, let's increase it to something like 5. Then here you have the start radius option, which basically means the radius of the start of the curve, or simply the bottom area. Then you have the end radius, and it means the radius of the end of the curve spiral, or simply the radius of the top area. Then the next parameter is the height, and as the name suggests, it controls the height of the curve spiral. And now by default, the rotation of the curve spiral is clockwise from the beginning. However, if I turn on this reverse option, the direction of rotation will be reversed, and now it will be anti-clockwise from the beginning of the spiral. For now, let's turn off the reverse option, and to convert it into a tornado, we first need to give some thickness to it. As a result, we'll be adding the curve to mesh node here. So press Shift plus A, go to curve, and in operations, select the curve to mesh node. Let's place it over here, and for the profile curve, we'll be using the curve circle node and connect it over here. So press Shift plus A again, go to curve, and in primitives, select the curve circle node. Let's place it over here and connect it to the profile curve. Now to reduce the thickness, go to the curve circle node and reduce the value of radius from here. So we'll keep it to something like 0.4, and now let's view it with the rest of our scene. So for this, we'll be connecting this curve to mesh node to the join geometry, and let's also delete the viewer node from here. And now here we have the curve spiral placed at the center. Now to move it up and change the scaling of this tornado, we'll be using the transform geometry node. So press Shift plus A, go to geometry, and in operations, select the transform geometry node. Connect it after the curve to mesh node, and by using the translation in the Z axis, we will change its position. So let's increase it and move it upwards like this. Let's also make it slightly bigger with the help of the scale values in the transform geometry node. So let's increase it to something like 2 or 3. Now to make it look like a real tornado, let's first reduce the start radius from here. So we'll keep it to something like 0.2 or 0.3. Let's also reduce the end radius value from here, and if you want to make it bigger in terms of height, then you can also increase the height parameter from here. And now we have the basic structure of the cotton candy tornado ready in the scene. Now let's also go to the render view, and right now only its shape is resembling the tornado. To make it look like a real tornado, we need to convert it from a mesh into volume. So for this, we'll be using the mesh to volume node. To add it here, press Shift plus A, go to mesh, and in operations, select the mesh to volume node. Let's place it over here after the transform geometry node. Now this tornado is slightly visible in the scene. However, we need to increase the density and the number of rotations in order to make it properly properly visible. So first of all, go to the rotations and increase it to something like 10. So I'll change it to a value of 10. Now let's reduce the height to something like 2 meters. Let's also go to the scale parameter in the transform geometry node and slightly increase it to something close to a value of 3. Then to increase the density of the volume, you can go to the mesh to volume node here and increase the density to something like 2 or 3. And with this, the tornado almost looks ready. However, it's up to you how you want to change these values. You can keep the number of rotations to any value which you think will look the best. Similarly, you can change the start radius value from here or maybe the end radius value like this. You can even control the height of the spiral from here. Then you have the scaling options here, so you can adjust these values yourself. Now to make it look like a cotton candy tornado, we'll be giving it some material. So press Shift plus A, go to material and select the set material node. Let's drop it after the mesh to volume node. Then go to the material properties, click on the new button and let's change the name of this material to cotton candy. Go to the set material node and select the cotton candy material. Now in order to create the cotton candy material, we have to change the window to the shader editor, and now we'll be using the principal volume node. So I'll delete the principal BSDF, press Shift plus A, go to shader and select the principal volume shader. Let's place it over here, and now I'll connect the volume socket to the volume in the material output. Let us change the color from here. So let's change it to pink color, increase the brightness from here and adjust the color like this. Now go to the emission strength, and we'll be using this emission strength and the emission color in order to create a slight emission effect around the tornado. So I'll go to the emission strength and we have to give it a very small value like 0.01, and for the emission color, we'll set the same pink color that we assigned here. So with my cursor over this pink color, I'll press Ctrl plus C, and to paste this color in the emission color, I'll take my cursor over this white area and press Ctrl plus V. I think that we should reduce the emission strength to a much lower number like 0.005, and with this we have a simple tornado with slight pink emission effect added around it. Now the next thing that we'll do here is to distribute these candies on different points on the faces of tornado, and to achieve this result, we'll open the geometry nodes editor again, and first we'll be adding the distribute points on faces node. So press Shift plus A, go to point and select the distribute points on faces, place it over here, and since it takes only the mesh as an input, as a result we can't connect it using the volume node in the mesh to volume. So I'll take the geometry socket in the transform geometry node and connect it to the mesh. Now to view the points on the tornado, take the point socket and connect it to the geometry in the join geometry node. Now here we have these points distributed on the different faces of the tornado. To reduce the number of these points, you can reduce the value in the density parameter to something like 0.5 or 1, and now the number of these points has reduced. Now to replace these points with the candies, we'll be using the instance on points node. So press Shift plus A, go to instances and select the instance on points. Let's place it over here after the distribute points on faces. Now if you remember, at the beginning of this chapter, we learned about the geometry to instance node, and we used it here in order to convert these candies into different instances. Then we used it on the instance on points node to place them at different points on the plane as instances. And for the tornado also, I'll be using the instance socket in the geometry to instance node and will connect it to the instance socket in this instance to points node. Now first of all, let's go to the density value and reduce it to something like 0.01. Now even though the density is reduced, however, you can clearly see that there are no candies placed around the tornado. All of them are appearing on the top of the tornado, and this is because we reduced the density in the distribute points on faces, and it is not the best way if you ever want to reduce the number of instances being placed on the points of faces. If you remember, we used the random value node with the boolean and connected it to the instance on points in order to fix the probability of these candies appearing on the plane. And similarly, we'll be using the same node in order to place these candies as the instances on different points of the tornado. So let's create its duplicate by pressing Shift plus D, and let's place it over here. We'll connect it to the selection socket in the instance on points. Let's also increase the density in the distribute points on faces node. So we'll increase it to a value of 10, and then to reduce the number of these instances, I'll go to the probability parameter in the random value node and let's keep it to something like 0.002, and this is how it looks. We now have these candies placed at different points on the faces of the tornado, but now the number of these instances is too high, so I'll directly go to the value of density and reduce it to something like 5, and let's also increase the probability to something like 0.003 or 0.004, and finally this is how the scene looks now. We have this tornado with the candies around it, and right now all of these candies are having the same rotation, which is their original rotation, and to give some random rotation to each one, we'll use the random value node. So I'll select this one, press Shift plus D to create a duplicate and place it over here, change the data type to vector and connect the value socket to the rotation in the instance on points. To increase the randomness, select all the 3 maximum values and let's increase it to something like 10. So you can try to change these values like the density, the probability and the amount of randomness in the rotation by using the maximum values. The higher the number in the maximum, more will be the randomness in the rotation of candies. Then to generate a different output with the same value of rotation, you can go to the seed option, and if I change it, then it will generate a different result. Now let's do one more thing, which is to improve the lighting in the scene. So I'll select this light in the scene collection, press Shift plus D to create a duplicate and move it in the X direction like this. Let's also move it in the Y axis and place it over here. Now press R to rotate the light and left click to finalize. Let's reduce the strength of this light to something like 2 or 3, and now this is how our candy world is looking right now. Now moving ahead, the next topic of today's chapter is understanding the separate components node. So first let's add it in the geometry nodes editor. Press Shift plus A, go to geometry, and in operations, here we have the separate components node. So I'll select it and place it over here. In this node, you can see that it takes geometry as an input and provides the output in the form of mesh, curve, point cloud, volume and instances. In simple words, it helps to separate the different components of geometry. So if I go to the join geometry node and place the separate components node after the join geometry node, then in this case, it will only display that component which is connected to the output. In this case, the mesh is selected. As a result, it is showing only the mesh component of the object. Similarly, if I connect the volume, then in this case, it will only show the volume component, which is the tornado. Then if I connect the instances to the output, then now here we have all the instances, or basically these candies, being displayed in the scene. So you can use the separate components node if you ever want to separate the different components of an object into mesh, instances, volume, etc. and then you can work on that specific component easily. However, for now, we'll remove the separate components node by pressing X, and let's connect the join geometry to the group output again. And now it's the time to understand the last concept of today's chapter, which is the sample index node. To understand it, we'll be adding a cube in the scene. So press Shift plus A, go to mesh and select the cube, press G and X and move it over here. Let's also turn on the solid mode from here, and now with this cube selected, go to the geometry nodes editor and click on the new button. Now to add the sample index node, press Shift plus A, go to geometry and in sample, select the sample index node. Let's place it over here. Now the sample index node has the geometry socket as the input, a value socket and the index parameter. So it basically takes a geometry as an input and then it will retrieve a particular value based on the index number. To understand it practically, let's connect it here. Now to view the cube, I'll take the geometry socket in the group input and connect it to the group output. And suppose you want to place a particular object on one of the vertex of this cube. Like if I go to the geometry nodes editor, press Shift plus A, go to mesh and in primitives, select a UV sphere. Let's place it over here. And now suppose I want this UV sphere to be placed at that position where a particular vertex of this cube is present. But for that, I need the exact position of that particular vertex. And this is where the sample index node can help us. Since by default, the point is selected as the domain, therefore, we can use this node to retrieve some information or some value about that point which has an index equal to 0. And since we need to calculate the position, so we also need to change the data type from float to vector. Now to tell this node that we want to retrieve the position, we'll be using the position node and connect it to the value socket. So press Shift plus A, go to geometry and in the read category, select the position node. Let's place it over here and connect it to the value socket. So now this sample index node will retrieve the position of that point of the cube whose index value is equal to 0. And to use this value, in order to place the UV sphere at that specific point of vertex, we have to use the set position node. So press Shift plus A, go to geometry and in right, select the set position node. Let's place it over here, connect the mesh socket to the geometry, and for the output, we'll be using the join geometry node. So press Shift plus A, go to geometry and select the join geometry node. Let's place it over here, and to view the UV sphere, I'll take the geometry socket of the set position node and connect it here. Let's switch to the wireframe mode in order to see both the cube and the UV sphere. Right now, the offset values are set to 0 meters. As a result, the UV sphere is placed at the center of the cube. However, if I take the value socket of the sample index node, which has the information about the position of that vertex of the cube which has an index equal to 0, and connect it to the offset, then now you can see that the position of the UV sphere will change to that specific location where the vertex of the cube has an index value equal to 0. Similarly, if I change the index value to 1, then the position of the UV sphere will change accordingly. So this is the use of the sample index node. However, we won't be practically using it in this chapter. So for now, I'll delete this by pressing X, and let's go back to the scene. Let's also turn on the render view, and this is how the final scene looks now. Today we understood lots of new concepts in geometry nodes and even started with the creation of this candy world. And yes, with this, we come to the end of this chapter. So our next chapter will be the chapter number 43, Geometry Nodes, Part 2 of creating a candy world. So don't forget to subscribe to our channel, press that notification bell so that you can get timely updates about the upcoming chapters. Thank you for watching and we'll see you in the next one.